Hey everyone, welcome back to Cracking the GRE Math Subject Test. We're on the linear algebra chapter, and this is the second question. This question is a little bit, it's not too hard, but it is a little bit tricky because it requires some fancy factoring that isn't even really linear algebra, it's just regular algebra. So we're given a linear system, three linear equations, except they're not really written in the normal way, like, with constants and x, y, and z. There's some a's, and there's an a's here, and then you're told that the solution is a, b, a. X equals a, y equals b, and z equals a. And you're also told that a is not an integer, and then you're asked to find the value of a plus b. So this problem is kind of convoluted, and it takes a second to understand what they want from you. But you just sort of have to start plugging things in. So we'll take this solution that they give us and plug it in. So that gives us, if you plug in x equals a, that gives you a squared. And then if you plug in y equals b, that gives you plus ab minus z equals a equals 1. That's the first equation. The second equation is a, x equals a, minus y equals b, so that would be ab, and minus z equals a, so that would be minus a squared, equals negative 1. And the last equation is a times x, well, x is a, so that's a squared, minus y is b, so that's minus b, plus az, where z is a, so that's plus a squared, all equal to 1. Alright, now from these three equations we somehow have to figure out what a plus b is. Well, the first thing we should notice is that the first two equations are actually just negatives of each other. See, there you've got an a squared here and a minus a squared here. You've got an ab and then minus ab, and you've got a minus a and a plus a, and then on the right side you've got a 1 and a minus 1. So this second equation doesn't actually give us any new information, so we can ignore it. So going back to the first equation and the last equation, well, the last equation we can rewrite as 2a squared, you've got an a squared and an a squared, minus b equals 1. Okay. Let's see if we can combine the first equation and the second equation somehow. What we'd like to do, since we have this a squared, we'd like to get this into the form of a quadratic equation. In order to do that, we need to have a 0 on the right side. So if we subtract these equations from each other, we'll have a 0 on the right side. So let's see what we get. I'm going to take the second equation, or the last equation, and subtract the first equation. That'll give me a squared minus b minus ab plus a equals 0. Okay, now we're going to have to do some fancy factoring. Let's take this a squared term and this ab term and factor out an a. That'll leave us with a minus b. And then we still have this plus a and this minus b, all equal to 0. Now we can look at it this way. A times a minus b plus a minus b. So if we factor out an a minus b, we'll have an a plus 1 left over, all equal to 0. So from this we know that either a is equal to negative 1 or a is equal to b. But since we're told that a is not an integer, we can cross out this solution and we're left with a equals b. So let's take this a equals b and plug it back into one of our equations. For example, the third one. Well, then we get 2a squared minus a, and I'm going to bring the 1 over to the left side to get it to look like a quadratic equation, minus 1 equals 0. Can we factor this? I think we can. 2a, a, 1 and 1. Now we need a minus and a plus, and we need it to add up to minus a. So we're going to have to put the minus here and the plus here, so that we'll get minus 2a and plus a, that's minus a. So from this, we know that either a equals positive 1 or a equals negative 1/2. And this will give us a equals 1, and this will give us a equals negative 1/2. Well, we know that a cannot equal 1 because the problem tells us that a is not an integer. So that means that a equals negative 1/2. And we also know that a equals b, so b also equals negative 1/2. Therefore, a plus b is equal to negative 1/2 and negative 1/2, which is just negative 1. So our answer is B.